dear students, welcome back to day 4 of PU2 Brahmastra Series. So today is Thursday and today is chemistry day, right? So we are going to complete the second chapter of organic chemistry, that is alcohols, phenols and ethers. So students, this is going to be a very important session. I'll be revising all the reactions that we have studied and we are going to solve questions topic wise. Okay, we will complete one topic and we'll solve some questions. So this will be really helpful for you, and if you're watching this video, you need to make notes of the questions. So write down all the questions in one place and answers so that you can do it in a you can revise it very quickly. Okay, so and as I tell you every time, please join our WhatsApp channel. You need to fill the form link will be there in the description section. All these notes and PDFs will be sent to you in your WhatsApp. Okay, so yes students, now let's get started. The mark distribution of alcohols, phenols and ethers. So this chapter carries 10 marks. Okay, 10 marks. So there will be 3 VSA, so it can be MCQs or fill in the blanks, and there will be 1 2-marker question. So total this became 5, and there will be 1 5-marker question. This 5-marker question is very predictable. Okay, we are very sure what questions will be asked. We'll be practicing those questions. Okay, now coming to this video index, so we will be discussing 10 MCQs, we'll be discussing 35 2-marker questions, and then we'll be discussing 5-marker questions 5. Okay, so almost you can say 40-50 questions we are going to discuss, and if you practice these 50 questions, then definitely you will be able to crack this particular topic. With all the questions you can definitely answer, I can guarantee you that. Okay, so yes students, now I want all of you to sit with a notebook and a pen. Okay, and you need to note down the questions, and if you know the answer, try to write it, otherwise you can see and write down. Okay, but today whatever questions we are discussing, these 50 questions you should learn after this video ends. Okay students, let's get started. Okay, fine. First question here, MCQ question is this one. Propane is allowed to react with HBr in presence of benzoyl peroxide, and the product is subsequently heated with aqueous KOH. Okay, the final product obtained is. So now what is the speciality of HBr in peroxide? Please comment down quickly. HBr in peroxide will give you anti-Markovnikov's rule product, right? If you remember. So now if I have propene, so I have like CH3, CH double bond CH2, right? Now if you add HBr in presence of peroxide, right? So what happens? Anti-Markovnikov rule is followed. That means the negative part will go to the carbon having more number of hydrogen. Okay, what I'm saying? Negative part will go to the carbon having more number of hydrogen. Now if you see here, there is 1 hydrogen and here there is 2 hydrogen. So negative part is what? Br minus is negative, H plus is positive. So negative part will go to the carbon having more number of hydrogen. So what I'll get here, we'll get CH3, CH2. Okay, and then if I want to add here bonds, this one will be Br and this one will be H. Okay, next you are treating it with aqueous KOH. Okay, so if you are treating it with aqueous KOH, so this is what? Simple. You have seen this reaction in haloalkanes, haloarenes chapter also. If with aqueous KOH, it is a substitution reaction. This bromine will be replaced with OH. So what I'll get here? CH3, CH2 and CH2 and OH, right? So that is your propane 1OL, option number C. Okay, I hope all of you are clear with this question. Next question. The ether C6H5O CH2 C6H5 on heating with concentrated HI produces. Okay, so you have here C6H5, okay, O, CH2 and then you have C6H5. Now this when you are treating with HI. Now you remember, whenever you have this phenol group, means there is one benzene ring with oxygen. If it is there, every time the bond will break here and one of the product will be phenol. Okay, so that is why this one will break here and this O will take this H. Okay, and this I will be attached here and I will get here this one CH2I. Okay, so we got phenol and C6H5CH2I. That is option number C here. Next, question number 3. In the following compounds, okay, you have to arrange them in the acidity order. Okay, acidity order. Now what about acidity order you should know? If you have electron withdrawing group, okay, then acidity increases. If you have electron donating group, then acidity decreases, right? Electron withdrawing group will increase the acidity, electron donating group will decrease the acidity. Now if you see here, we have which group? Here we have electron donating group, here NO2 is electron withdrawing group, here NO2 is electron withdrawing group. Right? Now, if you remember, the para position electron withdrawing group is acting better, right? Here it will withdraw through resonance and here it will withdraw through inductive effect, right? So that is why this one will be very stable, or this one will be highly acidic. So 4, you have only one option with that, so we can tell that answer is option number D. So after 4 there will be 3, and then after that it will be 1 and then 2, because electron donating group will decrease the acidity. Okay. Next, in which one of the following reactions phenol is not obtained? Okay, so if you treat with NaOH this will undergo decarboxylation, we will get phenol. But here if you see MgBr, okay, so here if you see this bond it is not easy to break this bond, okay, because we have this what I can say, partial carbon is sp2 hybridized, so this bond cannot break easily, so that is why this is not possible, option number B here. Next, phenol is weaker acid than acetic acid because, okay, so phenoxide ion is better stabilized by resonance than acetate ion. Acetate ion is better stabilized by resonance than phenoxide ion. Now, if acetic acid is a stronger acid, then its conjugate base, that is your acetate ion, will be better stabilized, right? So that is why acetate ion is better stabilized by resonance than phenoxide ion. Okay. Next, we have propene can be converted to 1-propanol by oxidation. Which set of reagents among the following is ideal to affect the conversion? So if you want to convert 1-propanol, you need anti-Markovnikov's rule, right? That happens with hydroboration oxidation, that is B2H6 with alkaline H2O2, option number B here. Next, a compound AC8H10O is found to react with NaOI and yields a yellow precipitate with characteristic smell. Okay, A and Y are, okay. So here the question is, you have A, okay, and this is found to react with NaOI produced by reacting Y and NaOH. So this NaOI, how is this one is produced? This one is produced by reacting NaOH plus Y. Okay, you need to find this Y. Now A is there. When A reacts with NaOI, we get what? Yellow precipitate. Okay. Now if you remember, yellow precipitate is due to the formation of CHI3, and this reaction is nothing but iodoform reaction. Okay. Now for any alcohols to show iodoform reaction, the condition is it should have CH3 CHOH group. CH3 CHOH group, right? Now where can we find this CH3 CHOH group? Let me see the options. So here we don't have CH3 CHOH. Here you can see here CH3 CHOH group is present. So this one will show iodoform reaction, and NaOH will react with I2 to give you NaOI. So that is why I2. So the correct answer here is option number C. Okay. Next, the compound A on treatment with Na gives B. Okay, so compound A on treatment with Na gives B, and with PCl5 gives C, and with PCl5 gives C. Okay, now B and C react together to give diethyl ether. Okay, so B plus C is diethyl ether. Diethyl ether. Now A, B and C are in the order of. Okay, so now if you see, it is reacting with B, okay, sodium, and there is Na to give you, and these two, so definitely this must be one alkoxide ion, okay, and when you treat it with Cl, this must be a haloalkane, right, and A must be one alcohol group. right? So if you see, we have first alcohol, option number C we can eliminate. So here we all have alcohol, and B has to be an alkoxide ion. Here we do not have alkoxide. In this option we have alkoxide, so option number D here, okay? And the C1 is your haloalkane, that is chloroalkane. Next, the structure of the intermediate A in the following reaction. So this is Cummins process, if you can remember, Cummins process of synthesis of phenol. So here what happens, O gets inserted here, right? So that is why the correct, so O gets inserted between this C and H group, right? So that is why the correct answer is option number C here. Next, the product of the following reaction, okay, so B2H6H2O2OH minus. So this is what? Hydroboration oxidation reaction, and it follows anti-Markovnikov's rule, okay? Now if you are adding CH3CH double bond CH2, with this what will happen? Anti-Markovnikov's rule will take place, and you will have H added here and OH added here, right? So that is propane 1OL. So we can have CH3, CH2, CH2OH, that is option number B, okay? Fine. Now we will go to the next topic. Before that, I want to discuss some methods of preparation of alcohols, a quick revision of the preparation of alcohols, then we'll do questions based on preparation of alcohols, okay? So the first method is from alkenes, okay? The first method is using alkenes. So alkenes, you can use H plus and H2O, okay? So what will happen? H and OH will be added, and here it follows Markovnikov's rule. And you can do hydroboration oxidation, just now we discussed, and it follows anti-Markovnikov's rule, okay? And this one will give you alcohols. First, clear? Now second one is your aldehydes and ketones. So if you reduce aldehydes and ketones, we will get alcohols. There are two reagents to reduce aldehydes and ketones. The first one is hydrogen palladium, and the second one is NaBH4. Okay, you will get alcohols again here. Another method is using acids and esters. So acids and esters can be reduced by using H2 palladium or lithium aluminium hydride, but this is good, or can you say more preferable reagent, okay? And then with Grignard reagent also you can prepare RMGX. So what will happen? This is O minus and C plus, and this R will attack here, this one will go here, OMGX will form, and then it get hydrolyzed to give you OH, okay? So these are the four methods: from alkenes, from carbonyl compounds, from acids, and from Grignard reagent, okay? Now we will do questions from these four methods, okay? Let's start now. First, write the product for the following reaction. So you can see here CH3, CH double bond CH2, H plus H2. So this one will follow Markovnikov's rule. H and OH will be added on both sides. So I will get CH3, C, OH, H, and CH2H. Okay, so this is Markovnikov's rule. Anti-Markovnikov's rule is CH3, CH, okay, CH2, OH, and H. Okay, so this one is Markovnikov's rule, or you can say propane. You can see the difference, right, where OH is added. Propane 2OL, and this one will be propane 1OL. Okay, so these are, now we are going to discuss two marker questions. The first one we are discussing on the topic of preparation of alcohols, and from that from alkenes. Okay, next we'll go, what is hydroboration oxidation reaction? Give an example. Okay, this is again from the preparation method. So here you need to write the reactions carefully. This question you can prepare, you need to learn it properly. So now see, alkenes react with diborane. Alkenes react with diborane to give trialkyl borane. Okay, alkenes react with diborane to give you trialkyl borane, which on oxidation with hydrogen peroxide in alkali give alcohol. This reaction is called as hydroboration oxidation reaction. This much is enough for the definition. This I have written for your knowledge, but you need to write only this much. What is that? Alkenes react with diborane to give you trialkyl borane, which on oxidation gives you alcohol, which on oxidation in presence of hydrogen peroxide and alkali gives you alcohols. This is called as hydroboration oxidation reaction. Now you need to write the example also. So I have taken propene here, and then we have taken diborane. Diborane means B2H6, but it is written as BH3 whole twice. Okay, now what will happen? Now see, the next point here is important. During this reaction, the boron atom is attached to the sp2 carbon carrying greater number of hydrogen. Okay, so now what happens? This bond breaks like this, H and BH2. Okay, now boron will be attached to the sp2 carbon having more number of hydrogen. So this side boron will get attached. So what will happen? H will attach here and BH2 will attach here. Okay, now again you are reacting with another molecule. Then what will happen? Again this whole group. Okay, in this H will be attached here and B will be attached here. So we will get this compound like this. We got trialkyl boron. Okay, now trialkyl boron on reaction with H2O2 in alkaline medium will give you the alcohol. Okay, that is the answer. Please note down this answer and you have to prepare this answer. Next, give two methods to prepare alcohols from carbonyl compounds. Okay, the second one, if you remember, carbonyl compounds, two methods to prepare alcohols from carbonyl compounds. How will you prepare primary alcohols from carboxylic acid? Give example. Okay, so first of all you can see the first one, carbonyl compounds are reduced to alcohols by addition of H2 in presence of catalyst like platinum, palladium and nickel. This is one way. You have to write two methods, right? The second method you have to write the same answer, carbonyl compounds are reduced to alcohols by addition of NaBH4, okay, in NaBH4 to give you alcohols. Clear? You have to write with example always. So I'll write question number 3, first one. Okay, this one I'm writing two methods, right? So I will take any CH3 CO CH3 suppose. Okay, so then I have taken here H2 and palladium. So this will give me CH3 CHOH and CH3. Okay, and next we have hydrogen and palladium, and next if we are giving it with what is that, okay, NaBH4. Okay, you have to write the same definition. In place of this hydrogen you need to write NaBH4. Okay, now this one will give you CH3 CHOH and CH3. Okay, clear? Now how will you prepare? So this one is done. Now how will you prepare primary alcohols from carboxylic acid? Give example. So here is the answer here. Carboxylic acid are reduced to alcohols by a strong reducing agent, that is lithium aluminium hydride. Now if you want to give example, you can take acetic acid CH3 COOH in presence of lithium aluminium hydride. This will give you CH3 CH2OH. Okay, clear? Fine. Next, question number 4. Write the equation to convert methanol to methanol and propanol to propanol by catalytic hydrogenation. This is very important. So here you cannot use any other method. Catalytic hydrogenation means addition of H2 in presence of catalyst. So you can just write down methanol. Methanol is what? HCOH in presence of hydrogen and palladium will give you HCOH, H and H. Okay, next you have propanol to propanol. We have propanol, okay, propanol to, you have H2 and palladium to give you propanol, CH3 CH2 CH2 and OH. Okay, clear? So you have to write only this method. You cannot use NaBH4 here. It will become wrong because the question has asked you by catalytic hydrogenation. So here also if you write two answers like this, you will get 2 marks. Okay. Next, question number 5. How to prepare alcohols commercially from carboxylic acid? Give equation. This is very important question. Now see, we have just seen that carboxylic acid, if you treat with lithium aluminium hydride, you will get alcohols, right? Just now we discussed. But lithium aluminium hydride is a very costly reagent. Okay, so commercially it is not feasible to use lithium aluminium hydride every time. Okay, so that is why what we do, we convert these carboxylic acids to esters. Okay, and then these esters are reduced with hydrogen and palladium, hydrogen and palladium, or catalytic hydrogen to give you alcohols. Okay, now see what I will just explain you. You have acids. Okay, acids, if you treat with lithium aluminum hydride, you will get alcohols, but lithium aluminum hydride is costly, so we will take another method. So acids are converted to esters. Okay, then esters are converted to alcohol with hydrogen and catalyst. Okay, now acids to esters, how will you convert? If you react with alcohol, right? Esterification reactions. So that is how is the commercially we prepare it. So I have written the answer, you can see here. Commercially, acids are first converted to esters, and then these esters undergo reduction in presence of H2 and catalyst. Now we can see a reaction here. So you can see first we have taken any acid group with alcohol, it is giving you ester group. Now esters with hydrogen and catalyst will give you alcohols. Okay, so you can write down this reaction. Got it? Okay, so that is the commercially method of preparation. Next, question number 6. Okay, sorry, this is question number 6. Okay, yes, sir. How to prepare primary, secondary and tertiary alcohols from Grignard reagent? Give equation. This is also very important question. Now see, for primary alcohols, the only aldehyde that is possible is formaldehyde. For secondary alcohols, you can take any aldehyde, and for tertiary alcohols, you need to take ketones. Okay, so you can see for primary alcohols by treating formaldehyde with Grignard reagent. Next, for secondary alcohol by reacting any other aldehyde other than formaldehyde with Grignard reagent, and tertiary alcohol by treating ketones with Grignard reagent. You also need to give equation for this. So I will give equation here. Okay, so now we'll start with first one, that is if I taking HCOH, okay, and you are treating with CH3MgCl, Grignard reagent. Okay, how to attack I am teaching you. See here, this is minus, this is plus. Okay, carbon oxygen is more negative, so minus and plus. In Grignard reagent, this is plus and this is minus. So what will happen? The negative one will attack here and this O will go here, right? So what I will get? I will get here C, okay, then I have H, okay, and then I have CH3 here, right? I have attacked this CH3 here, and this O minus here will take the MgCl, and here I have H. Now if you do hydrolysis, just if you do H3O plus, this OMgCl will get converted to OH. Okay, so this one will get converted to OH. Okay, CH3, CH2, OH. So we got a primary alcohol here. Now second one is the reaction of any other aldehyde. If I take CH3, COH, okay, and I am reacting it with CH3MgCl. Okay, now here again minus and plus, this one will attack, this is minus and this is plus, this one will attack here and this one will go here. After that, if you do hydrolysis, what will happen? So I will get CH3C, and here I have CH3, right, this is H, and here I have OMgCl, and that gets hydrolyzed to OH. Okay, so let me erase this one. Okay, now if you see the next one, tertiary alcohol, we have CH3, CO, CH3, ketone group is there, and you are treating it with CH3MgCl. Okay, now this is minus, this is plus, this is plus, this is minus, and here you can attack, here you can attack. So we will get CH3COH, then you have CH3 and CH3. So this is your tertiary alcohol, this is secondary alcohol, and this is primary alcohol. Clear? So you can see with Grignard reagent we can get all the three types of alcohols. Okay, so for primary alcohol we need formaldehyde, secondary alcohol any other aldehyde, and for tertiary alcohol ketones. Okay, Next, question number 6. Boiling points of alcohols are higher than other classes of organic compounds like hydrocarbons, ether, haloalkanes of comparable molecular mass. Give reason. Alcohols are soluble in water. Why? So both the answers for this is your hydrogen bonding. Okay, so answer for this is hydrogen bonding. So you can write down here, due to hydrogen bonding the intermolecular forces are more. That is why it is difficult to boil them, and that is why they have higher boiling point. And here you have to write alcohols are soluble in water because they are able to form hydrogen bond with water. Okay, here what is there? Here there is hydrogen bond between two alcohol molecules, right? And in this case what is there? There is hydrogen bond between alcohols and water. Clear? Okay, very easy question. Next we are going to now questions from, so preparation over. We have done question from alkenes, we did questions on carbonyl compounds, then we did question on Grignard reagent. Okay, these were the three methods, right? Alkenes, Grignard reagent, and your carbonyl compounds and acids. We did all the 4 compounds. Now we are talking about reactions of alcohols. Okay, so reactions of alcohols is of 2 types. One is the first thing that we are going to study under reactions of alcohol is its acidic nature. Okay, due to its acidic nature, what happens, like, see, if I talk about reactions of alcohols, we have 2 categories of reactions. One where OH bond is broken and one where CO bond is broken, right? Under this OH bond is broken, you have reactions like reactions with metal, okay, reactions with metal, and you have esterification reaction. Okay, now we are going to discuss the first part where OH bond is breaking. It can react with metal, Na. Okay, if it is reacting with metal, what will happen? You will get alkoxide ion, sodium alkoxide, and hydrogen gas. Then to give you esters, okay, it can react with 3 different things to give you esters. What are they? First, alcohol can react with acids to give you esters. It can react with anhydride to give you esters, and it can react with acid chlorides to give you esters. Okay, so you have reactions with, to esterification we need, it can react with carboxylic acid, it can react with anhydrides, and it can react with acid chlorides. Okay, fine. So we will see questions from here now. What is the what is the effect of the electron donating substituents on the acidity of alcohols? Okay, so we have seen here that reactions, when we are talking about reaction with, when OH bond is breaking, at that time alcohols are behaving as acids, because anything which releases H plus is an acid, right? So that is what is here. So effect of electron donating groups on acidity of alcohol. So here you should remember, electron donating group will decrease the acidity, withdrawing group will increase the acidity. Next, alcohols are weaker acids than water. Give reason. So you can see, if you have alcohols ROH, okay, now when it gives you one H plus, you have RO minus, and you have HOH, and you give H plus. In water you have OH minus, right? Now what happens? This negative charge is destabilized due to the electron donating group of this R, right? But here there is no electron donating group, this is more stable. If this is more stable, then water will be a stronger acid. So that is what you can see, electron donating group will decrease the acidity, and alcohols are weaker acids because the alkoxide ion means the one which is formed after the release of H plus, RO minus. Alkoxide ion is destabilized due to the electron donating nature of the alkyl group. Okay, that is why alcohols are weaker acids than water. I hope this answer is clear. So students, now let us see the next question, that is question number 8. What is esterification reaction? Give an example. Now see, direct question if it asks, it is very simple, but the question can be framed in different word like this, that what happens when ethanoic acid reacts with methanol? Whenever you see one acid and an alcohol reacting, it is nothing but your esterification reaction, right? Next, you need to give the equation for this. Then what is the name of the reaction? So how am I going to answer this? First, if I want to explain what is an esterification reaction, okay, so one second, yeah, what is an esterification reaction? The reaction between an acid and an alcohol in presence of concentrated sulfuric acid to form esters is called as esterification reaction. That is clear. Now you need to give an example here. So I will take this particular thing, one second, yeah. I will take this as an example and make you answer, like I'll make this reaction as an example for this one, okay. You have ethanoic acid, so you have CH3, COOH, and then you have methanol, you have HOCH3, then you have concentrated sulfuric acid OH. So what will happen here? Water will move, okay. Now if you see this one, it will be CH3, C double bond O, and then O and CH3, right. So this is the ester that is formed. Now what is the name of this reaction? So the name of this reaction is nothing but esterification, okay. Next, question number 9. Before going to that, we'll go to and check some other reactions of alcohols. Now if you remember, I told you alcohols have two types of reaction. One where there is OH bond is breaking. Under that we have acidity. We are talking about acidic reactions like like the reaction with metals and the acidity order. Then the next thing is esterification. Now we have the reactions where there is a breaking of CO bond is breaking, okay. Here we have different types of reaction, and under that first one is your reaction with HX, okay. Next reaction with PX3, so this one will give you RX. Next you have reaction of dehydration reaction, that is if you react with concentrated H2SO4 you will get dehydration, and the fourth one here after this is oxidation, okay. So four types of reaction under cleavage of CO bond. First is with HX, second one is with PX3, third one with H2SO4, that is dehydration, and here you should remember tertiary, secondary and primary is the order of dehydration reaction, and fourth one is oxidation reaction, okay. Fine. Now let us see this one, that is what is, so now we are discussing this one, reaction with HX, okay. What is Lucas reagent? How would you distinguish between primary, secondary and tertiary alcohols by Lucas reagent? Okay, very important question again. So now what is Lucas reagent? Lucas reagent is a mixture of zinc chloride and concentrated sulfuric acid. Lucas reagent is a mixture of anhydrous zinc chloride and concentrated H2SO4. Now how does it help you to distinguish between primary, secondary and tertiary alcohol? So you can write down, take an example of tertiary alcohol, okay, CH3, or you can write down like this, one second, you do not have to take example, and just you can write like this, that if you have tertiary alcohol, okay, you have secondary alcohol, okay, and you have primary alcohol, okay. Now tertiary alcohol with Lucas reagent, okay, will give you turbidity immediately, okay. Now if it is secondary reagent, secondary alcohol, if you take Lucas reagent, you will get turbidity after 5 minutes. And if it is primary and if you take Lucas reagent, it will be no reaction, okay. So in where I am writing Lucas reagent, you have to write anhydrous ZnCl2, okay, and H plus, okay. That is Lucas reagent. You can write down this, then you can differentiate. If you are just taking an alcohol and adding Lucas reagent and immediately you see turbidity, then yes, that is a tertiary alcohol, right. Like this you can find out. Okay, now we are going, I told you the fourth one, the fourth reaction where this CO bond is breaking is your oxidation reaction, right. When CO bond is breaking, there we had four types of reaction. First one, again let us revise, the first one is reaction with HX, that we have done a question on Lucas reagent. Then reaction is with PX3, third one dehydration reaction, and fourth one is oxidation, and under oxidation we have these all things to discuss. Let us discuss them quickly. See, oxidation, primary alcohols can be oxidized to aldehydes using the oxidizing agent, that is CrO3. Primary alcohols on oxidation gives you aldehydes, and if you have taken secondary alcohols you will get ketones, okay. So primary alcohols will give you aldehydes and secondary alcohols will give you ketones. Tertiary alcohols will not react. Now there is only this one is present. There is another reagent also, that is PCC. PCC, primary alcohol, will give you aldehyde, secondary alcohol will give you ketone. Okay. Now here I want to add one more thing, that if you have primary alcohol, okay, it can be converted on oxidation to aldehydes. The reagents that we can use is CrO3, or you can use PCC. Now if you want to convert this to this, that is alcohols to acids directly, then you need strong oxidizing agent like KMnO4, okay, or K2Cr2O7, right? Okay, now if you see this one here, that copper at 573 Kelvin, it is also a reaction. Here you can convert primary alcohols to aldehydes, secondary alcohols to ketones, and if you have a tertiary alcohol, we get alkene. Okay, this is very, very important. Here you see tertiary alcohols will not react in these two cases, but with copper at 573 Kelvin, tertiary alcohols will react, right, and it will give you alkene. Clear? So that is all about oxidation. So now let us see the 10th question. What happens when vapors of primary, secondary and tertiary alcohol passed over heated copper at 573 Kelvin? You can see this question was asked in 2016, 2022. So a very important question. The same thing you can write down as an example. So first, if you want to write in terms of words, you can write down primary alcohol. Okay. Primary alcohol will give you aldehydes. Secondary alcohol, you need to write it in sentence, okay. Secondary alcohols will give you ketones, and tertiary alcohols, okay, will give you alkenes. This is the reaction. Now if I want to write the reaction here, so primary alcohol is CH3 CH2OH, and with this one, that is copper at 573 Kelvin, will be CH3 CH2, okay, CH3COH, okay. We will have here CH3CHO, okay. Next you have secondary alcohols, CH3CHOH with CH3, and if I use this one will give you CH3CO and CH3, okay. Next, if you treat it with CH3 whole 3 COH with this copper at 573 Kelvin, will give me CH3 C double bond CH2 and CH3, okay. Clear? Fine. Next we'll go to question number 11. So this is from the commercially important alcohols. What is rectified spirit, what is absolute alcohol, and what is denaturation of alcohol? These are certain things that can be asked in terms of your what I'll say in MCQs or something, it can be asked. So we will just check this one. So rectified spirit is 95.5% of ethanol and 4.5% of water, okay. Absolute alcohol means 100% of pure ethyl alcohol. Next, if you have what is denaturation of alcohol, denaturation of alcohol means damaging the alcohol so that it cannot be consumed, okay. So commercial alcohol is made unfit for drinking by mixing, this is important, by mixing copper sulfate, which will change the color, and pyridine, okay, and methanol. So you will add copper sulfate, pyridine and methanol to make that alcohol unfit for drinking. Copper sulfate, pyridine and methanol. Okay. Next, question number 12. Describe the manufacture of ethanol from fermentation of sugar molasses. Okay. So here first I will explain what happens. Sugar is sugar means from cane sugar. Okay, that contains sucrose. Now this sucrose undergoes hydrolysis to give you sugar. That is your glucose and fructose. Now glucose and fructose undergo further fermentation to give you ethanol. Okay, so you can see here first step what is happening. See, the sugar in the molasses, sugar cane or fruit such as grapes is converted to glucose and fructose in the presence of an enzyme, that is invertase. Okay, so first from sugar cane or from sucrose we get glucose and fructose by an enzyme called invertase. Now glucose and fructose undergo fermentation in the presence of another enzyme, that is zymase, which is found in yeast. Okay, so now you can see the reaction here. First, this is sucrose in presence of invertase gives you glucose and fructose. Now anyone, you can take glucose or fructose in presence of zymase is giving you ethanol and carbon dioxide. Okay. Fine, next question number, okay, now we'll go to, so we have discussed the reactions of alcohols, the preparation methods of alcohols. So if you remember, in preparation methods we have 4 methods: from alkenes, from carbonyl compounds, from, next tell me, after carbonyl compounds, from acids, and using Grignard reagent. Now if we talk about reaction, we have 2 types of reaction where there is cleavage of OH bond, where there is cleavage of CO bond. For cleavage of OH bond, we have reactions based on acidity and esterification. For cleavage of CO bond, we have what reactions? We have again 4 types of reactions here, right? One is your oxidation, dehydration, okay, and 2 more were there, right? What were there? See, now I am not able to recall it. So what I'll go and check it, okay? So that is called as active recall. So you can just go and check what were the reactions. Yeah, I got it now. HX, that is your Lucas reagent, and with PX3, then dehydration and oxidation, right? So this is how you should also recall and answer to your, and this is how you will remember. Now we'll go to phenols. Preparation of phenols, there are some methods, very important. Every time each of these methods are equally important. So first one is from sulfonic acid, okay? So you can take oleum, okay, and if you treat it, that is concentrated sulfuric acid, you get this one, okay, sorry, this is oleum, okay, 1 second, okay, so yeah, once you take benzene and treat it with concentrated sulfuric acid, you get benzene sulfonic acid. Then if you treat it with NaOH and H+, you will get phenol. Okay, the first one. The second one is by your cumene. This is the most important and commercial method. Okay, questions have been asked repeatedly from this method. Okay, so that is why you should remember here. Okay, this cumene is, this is called as cumene, and its IUPAC name is isopropyl benzene. Okay, isopropyl benzene. So when you first add oxygen, what happens? This OO bond, this bond is there. Then if you treat it with H+ and H2O, you will get phenol and acetone. Okay, that is the second method here. Now you can treat it with chlorine. Okay, like you can take any haloarenes, and at very high temperature and high pressure we get sodium phenate, and then if you just treat it with HCl, you will get OH, right? Similarly, if you take aniline and then you get benzene diazonium chloride, and then if you provide water and you warm it, then you will get OH. Clear? So these are the 4 different methods for preparation of phenols. Now we will see questions from this. Okay, fine. How would you prepare phenol from benzene via sulfonation? Okay, how do you prepare phenol from benzene via sulfonation? That is the first question. How would you prepare phenol from diazonium salt? How would you prepare phenol from cumene? Okay, so we have just remembered this thing you have asked. This question has been asked many times. Okay, I have just written 2 years, but it is a very important question. So now if you see the answer, first one, I want to write very simple answer here. Benzene is treated with oleum to give benzene sulfonic acid, right, which on hitting with NaOH followed by acidification gives you phenol. So if you can see here, I have written exactly the statement of this reaction. Benzene treated with oleum to get benzene sulfonic acid, heated, or you can, if you don't know whether it heated is there, you can just reacted, write down. Reacted with sodium hydroxide in presence of H+ to give you phenol. Okay, next one is diazonium salt. So diazonium salts are hydrolyzed to phenols by warming with water, or you can just write down diazonium salts are reacted with warm water to give you phenols. Reactions, if you want to see, first I have taken aniline, then you get benzene diazonium chloride, then warm water, and you will get phenol here. Okay, now next one is your cumene one. So this is important here. So cumene is oxidized in presence of air to give you cumene hydroperoxide. It is converted to phenol and acetone by treating it with dilute acid. So you can see the reaction here. First, cumene is oxidized in presence of air to give you cumene hydroperoxide, and then it is converted to phenol and acetone by treating with dilute acid. Clear? Okay, now let us see the next question, question number 14. Alcohols are, okay, now we have come to chemical properties of phenol. Okay, now we'll talking about chemical properties of phenols. Under that also, here first we will talk about acidity, then we will talk about the different reactions. Okay, so talking about the acidity of phenols, alcohols are less acidic than phenols. Okay, and give reason for this. Give a chemical reaction to show that phenols are more acidic than alcohols and water. Okay, so this one, if you see, phenol, alcohols are less acidic than phenols, that is because of the resonating structures of phenoxide ion, right? Now if you see what is, whenever an acid is there, if you have this phenol group, okay, OH is there, it is an acid group, H plus will go, so this one will come as O minus, right? Now this negative charge is undergoing resonance, and due to resonance I can say that this negative charge is undergoing or is in what we say, is continuously or is distributed, delocalized. Okay, so that is why that is more acidic. Then give reason, you can draw the resonating structures and show here. So as I can say here, in alcohols the alkoxide ions, okay, it is just a 2-marker question, you need not draw the structures, you can just see here. In alcohols the alkoxide ions are not stabilized by resonance, but in phenols the phenoxide ions are stabilized by resonance, so that is why alcohols are less acidic than phenols. Okay, next give a chemical reaction to show that phenols are more acidic than alcohol and water. Now see, alcohols, we have just seen the reaction, alcohols will react only with sodium metal but cannot react with sodium hydroxide, because sodium hydroxide is a strong base, right? So it should react with a strong acid, but alcohols cannot react with that, but phenols can react with aqueous sodium hydroxide, which shows that phenols are stronger acid than alcohols and water. Okay. Next, question number 15, what is the effect of the following groups on the acidity of phenol? Again, this is very simple. If you know, you have electron withdrawing group, it increases the acidity. Electron donating group, it decreases the acidity, right? CH3 is an electron donating group, so what will happen? Acidity will decrease. Okay, and NO2 is electron withdrawing group, so what will happen? Acidity will increase. Clear? Next, question number 16, among orthonitrophenol and phenol, which is having higher pKa value? Okay, very important question this one. Here you remember certain points, that if acidic strength, or if acid, I say acidic strength is more, or it is a strong acid, okay, if it is a strong acid, then what will happen? If it is strong acid, then the Ka value is higher, okay, but pKa value is less. Got this point? Now if I want to see here, orthonitrophenol and phenol, which is more having higher pK value. So the first point I will write here is orthonitrophenol, okay, orthonitrophenol is more acidic, than phenol. Why? Because of NO2 group, which is an electron withdrawing group. Clear? Next, second point is higher, which is having higher pKa value, okay, which is having higher pKa value. If it is more acidic, its pKa value will be less, right? So because orthonitrophenol is more acidic, so its pKa value will be less. Then higher pKa value will be of what? Higher pKa value will be of phenol. So phenol has higher pKa value. Okay, clear? Next question. Okay, now we will go to I think this slide okay. Now here what happens, this esterification reaction, right? This esterification reaction is applicable to both alcohols and phenols, okay? So that is why I have added here. Now in case of this R, what we can think of is AR, okay? Like for this is AR. Phenol can react exactly the way alcohols reacted to give you esters, with acids, with anhydrides, with acid chlorides, with sodium it can be react, okay? So that is why I added here. So now if you see, the question is, how do you prepare aspirin from salicylic acid? Give the IUPAC name of aspirin, okay? So this is again an important question. So it's based on this one, esterification reaction. So salicylic acid reacts with acetic anhydride in presence of concentrated sulfuric acid to give aspirin, okay? So now salicylic acid means you have OH, salicylic acid is OH and COOH, okay? Reacts with acetic anhydride. So I will show you the reaction here. This is salicylic acid, reacts with acetic anhydride, CH3CO whole to O. In presence H plus, so what will happen? You will get OCOCH3, and this is what is your aspirin, okay? So now the question is asking you to tell the what we say IUPAC name of this one. So if you see, it is on the second position, you have this acetoxy group. So 2-acetoxy-benzoic acid. 2-acetoxy-benzoic acid is the IUPAC name of aspirin, okay? Next, question number 18. Before going that, we'll discuss the reactions of phenols. So one you have already seen, with Na it will react, and we have seen that phenol will also react with NaOH, and this reaction shows that phenol is more acidic than alcohols and water. If the question just now we see, tell me a reaction which shows that phenols are more acidic than alcohols and water, you need to show this reaction, okay? Now phenols can also undergo different aromatic substitution reaction, electrophilic substitution reaction. So here we are talking about, so phenols have, the first here is electrophilic substitution reactions. Then we have reaction is with Kolb's reaction. Then we have Reimer-Tiemann reaction, I am just writing in short, okay? And then we have reaction with zinc dust, and next we have last one is your oxidation reaction of phenol. So in this slide we are talking about the electrophilic substitution reaction of phenols, okay? So if phenol is treated with dilute HNO3, we get NO2 at ortho and para position. If you treat with concentrated nitric acid, we get NO2 in all the 3 ortho para positions, and this product is called as your picric acid, okay? Now if you see Br2 and CS2, it will add bromine at ortho and para position. If you take only bromine water, it will add bromine in all the 3 positions. Next, if you treat it with NaOH, okay, we get first phenoxide ion, O minus and Na plus, and then if you treat it with carbon dioxide, we get salicylic acid. This reaction is nothing but your Kolb's reaction, right? In Kolb's reaction, first benzene is treated with NaOH and then with carbon dioxide and H plus, okay? Fine. Now let us see the next one here. Okay, now you can see the substitution takes place at ortho and para positions. The question is about that here. Electrophilic substitution reaction of phenol occurs at ortho and para position, give reason. So whenever you think if the electron density increasing at ortho and para position, then substitution will take place at that position, right? So phenol has OH group which increases the electron density in the benzene ring by donation of the lone pair of electrons on oxygen atom at ortho and para position. So you can write like this: phenol has OH group which increases the electron density in benzene ring at ortho and para position by donating the lone pair of electrons on oxygen atom. Okay, this please add this one at ortho para position. Okay, after that you can write down by donating. Okay, just a small mistake, please correct it. Sorry students, please correct it. Okay, now if you see here, you can show by resonating structures. So you can see OH, this bond comes here, you get a negative charge here, again this comes here, you got a negative charge here, then again there is a, so you see the negative charge is coming at ortho, para and ortho position, right? So that is why this is the there is substitution taking place at ortho and para position. Okay, Next, among ortho and para nitrophenols, which has higher boiling point and higher vapor pressure? Okay, so this is also a very important question. So if you have ortho and para nitrophenol, so what happens in ortho nitrophenol? The structure is like this, right? Ortho nitrophenol. Okay, so in ortho nitrophenol, what happens? There is intramolecular hydrogen bonding. Okay, but if you see ortho, we have para nitrophenol. I can draw it like this. Okay, so in this case, what happens? There is intermolecular hydrogen bonding. Intermolecular hydrogen bonding is formed. So now higher boiling point, just imagine you want to boil it, right? So if the molecules are tightly bounded to each other, right, then it will be very difficult to boil them. So it will require more time or higher temperature. So which one will boil at higher boiling point? The or para nitrophenol. Why? Because of intermolecular hydrogen bonding. Okay, so A will be, but here you just need to write the answer. Which one has higher boiling point? Para nitrophenol. Okay, para nitrophenol, and reason you can write intermolecular hydrogen bonding. Next option, second question, which will have higher vapor pressure? Now see, higher vapor pressure is created when easily the molecules will evaporate. Easily they will evaporate and they will collect, and the vapor pressure will be higher. So if there is intramolecular hydrogen bonding, okay, intramolecular hydrogen bonding, these molecules can evaporate easily and the pressure, the vapor pressure will be higher. So here the answer will be ortho. Okay, I think I have given the answer, yeah, ortho nitrophenol due to intramolecular hydrogen bonding. Okay, ortho nitrophenol, okay, due to intramolecular hydrogen bond. Okay. Next, question number 20. What happens when phenol reacts with dilute and concentrated HNO3? Write the reaction. So here you can write down, when it reacts with dilute HNO3, you get ortho and para nitro products, and with concentrated HNO3 it gives you picric acid. Okay. Now if I want to, I want to write the reaction here. So students, you can write down the sentence, the first one. When you react phenol, okay, with dilute HNO3, it gives you ortho and para products. Okay, so you have OH and you have NO2 group, plus you have OH and NO2 group. Okay, next, if you have concentrated HNO3, okay, so that will give you picric acid, OH, NO2, NO2 and NO2. Okay, so that you can write, and here you can write down in sentence the first part, that phenol reacts with dilute nitric acid to give you ortho and para products. Next, question number 21. Orthonitrophenol is steam volatile but not para-nitrophenol. Explain. So, or steam volatile means it can be easily vaporized. So, the reason you know, orthonitrophenol has intramolecular hydrogen bonding. Now, how to separate ortho and para-nitrophenol? It is due to you can use steam distillation. Okay. So, orthonitrophenol is steam volatile because of intramolecular hydrogen bonding, and how to separate them? By steam distillation. Okay. Next, question number 22. Name the product formed when the phenol reacts with bromine water and bromine in CS2 and CCl4. So, here also if you see 22A, bromine water, what I will get? We will get all the three positions will be occupied. Okay. So, here you can write 2,4,6 tribromo phenol. Okay, and next you have bromine in CS2. So, you have like this OH and bromine here plus OH with bromine here. Okay, so you will get what? Ortho and para bromo. Okay, you need to write the name of the compound, right? So not like this, you have to write the correct name. So I can write 2-bromophenol, 2-bromophenol and 4-bromophenol. Clear? Clear this one. Next, now we are going to reactions of phenols. So under, like, I want to summarize here reaction of phenols. First is reaction with Na, second reaction with NaOH, right? See, active recalling, we are doing active recall, right? After that, what we said, we have electrophilic substitution reaction, right? I'm just writing substitution reaction. Under this substitution reaction, what we all have, we have halogenation, right? Halogenation and nitration. Okay, then we have Kolb's reaction. Okay, then we have Raymer-Tiemann reaction. Okay, then we have reaction with of phenol with zinc dust, and next we have, after zinc dust, what we get, I'm recalling, after zinc dust, oxidation. Okay, so we have discussed these all reaction in that previous slide. So we are discussing these three reactions here. So if you treat with CHCl3 and this one, we get O minus Na plus and CHCl2. So this is an intermediate form. Again, if you treat it with NaOH, we get CHO, and then if you treat it with H plus, we get benzaldehyde, right? So that is, or you can say salicylic aldehyde, sorry. So that is your which reaction? This is your Raymer-Tiemann reaction. Okay, spelling may be wrong, just check it. Raymer-Tiemann reaction. Now if you treat it with zinc dust, what we are getting? Zinc dust will give you benzene and zinc oxide. If you do oxidation with Na2Cr2O7, or that is called chromic acid, we will get benzoquinone. Okay, we will get benzoquinone. Okay, fine. So now let us see the next question. Explain the Kolb's reaction, or how do you convert phenol to salicylic acid by Kolb's reaction? You can see how many years these questions have been repeated. Very, very important question. So Kolb's reaction, if you remember, how was it? We have taken benzo. Let us first recall. We have phenol. We treat it with sodium hydroxide. We get phenoxide ion, and then we treat it with carbon dioxide and H plus to get salicylic acid. So if you see here in Kolb's reaction, sodium phenoxide, okay, reacts with carbon dioxide followed by acidification to give you salicylic acid. So reaction, if you see, we have first, so phenol, we get sodium phenoxide, carbon dioxide and H plus to give you salicylic acid. Okay. Next we have, that is the question, yes, 2 mark you will get here. Next, what is Raymer-Tiemann reaction and explain. So with example you have tried. So phenols on reacting with chloroform, okay, in the presence of sodium hydroxide followed by hydrolysis gives you orthohydroxybenzaldehyde, and this reaction is known as Raymer-Tiemann reaction. So how I have written, first phenol is reacting with CHCl3 and NaOH, okay. Phenol on heating with chloroform in the presence of sodium hydroxide at this 340 Kelvin, you can leave it, followed by hydrolysis, okay. So this is all intermediate, we are not talking about this. Followed by hydrolysis gives you orthohydroxybenzaldehyde or salicylic aldehyde, and this reaction is called as Raymer-Tiemann reaction, okay. Next, question number 25, name the product formed when phenol is treated with CHCl3 in presence of NaOH followed by hydrolysis. So this one is, we just discussed, salicylic aldehyde, okay. Now if you treat it with CCl4, okay, we will get salicylic acid, okay. Salicylic aldehyde we will get here, and here we will get salicylic acid. It's CCl4, okay. This is also important question. Next one, 26th, what happens when phenol reacts with zinc dust? Explain the oxidation of phenols. So this also we have just discussed. Zinc dust, if it is reacting, we will get benzene and zinc oxide, right? Phenols on heating with zinc dust will give you benzene and zinc oxide. If you want to write the reaction also, you can write down, very simple reaction, phenol, okay, in presence of zinc dust will give you benzene and zinc oxide. Next, explain the oxidation of phenol. So for oxidation of phenol you need chromic acid, so Na2Cr2O7, okay, and this one will give you benzoquinone, okay, clear. Next 27. So now we have come to ethers, okay. Explain Williamson ether synthesis with an example. Very important question. You can see how many times these questions have been repeated, okay. Williamson ether synthesis, what happens? You have an alkoxide ion and you have an haloalkane, and they react in presence of sodium to give you ethers, okay. So alkyl halides on heating with alkoxide, alkyl halides and alkoxide in alcoholic medium gives ether. The reaction is called as Williamson ether synthesis. If you want to give an example, you can just take any example here, like CH3O minus Na plus plus Cl CH3, okay, in presence of sodium. Oh sorry, yeah, you need alcoholic medium, right? So we can just write down like this, and here what will happen, NaCl will go out and we will have CH3O and CH3, right? This is the example, clear. Next, what I was going to say something, yeah, here one condition that you should remember is this Rx group. This Rx group should always be what? A primary halide. Should always be primary halide, okay. Now let us see question number 28. Which of the following is better method for the preparation of tert butyl ether? Give reason. So you should remember, the first you need to answer which is better method, okay. So if you see, I told you that you have always an alkoxide ion and a alkyl halide, right? And alkyl halide should be primary one. Here you see this is a tertiary alkyl halide, so this is not the correct one. Here you see this is primary alkyl halide and this is your yeah, so I can say that the second one is a better method, is a better method. Now what is the reason for that? Reason you need to write. What is the reason for that? That here in second, the Rx is a primary alkyl halide, primary alkyl halide, okay, clear. So next question, what happens when diethyl ether is heated with? Okay, so you have here diethyl ether. So generally what happens when ROR is there, okay, and you treat it with HI, so you get ROH plus R dash I, okay, this is what will happen. Now how the bond will break and all that we will discuss with questions, but now let us see the first question. Diethyl ether, that means you have CH3, CH2, OCH2 and CH3, and when you treat it with HI, okay, so because this both side it is same, so doesn't matter, you can just break any side and you will get CH3 CH2 OH plus CH3 CH2 and I, okay. Now if you treat it with excess of HI, then what happens? This part, right, this OH, so this gets protonated again and we get CH3 CH2 O plus H2, and then you get this I minus attacks on this one, this comes out and we get CH3 CH2 and I, okay. So with limited amount of HI you will get ethanol and ethyl iodide, but with excess of HI what will get? You will get you will get ethyl iodide and water, okay. So that is the product here. I have written here plus water, okay. I hope it is clear, or let me write it clearly so that you don't get confused. I'll erase this one, okay. So 1 second, yeah, with A you will get C2H5OH and C2H5I. With B what you will get? C2H5I plus H2O, okay. Next question number 30, complete the following equation, mention whether it is SN1 or SN2. So now you see here, when you break this compound, right, there is two possibility. The compound can break here, okay, and you will get O minus and plus. That is one possibility. Or the compound can break here, you will get O minus and CH3 plus. Now see, if there is a tertiary group, then always the reaction followed method is SN1, and this group will break, the bond will break here, and we get a plus charge here and a minus charge here. Now, and here what we have I minus and H plus, right? So this plus will take this I minus, and this O minus will take this H plus, and what we will get? We will get CH3, C, CH3, CH3, and we will get I here. And if you take this O minus, here H will be attached, so we will get CH3OH. Clear? So these are the products. Now complete the reaction. You will complete like this. What is the mechanism? SN1 mechanism is followed because we have a tertiary group here. Okay. Now question number 31. How is HX reacts with alkyl aryl ether? Explain with an example. So whenever there is alkyl aryl ether, always the product will be alkyl iodide and you have phenol group. Okay, so you can see here alkyl aryl ethers react with HX to give you phenol and alkyl halide. Now if I want to write an example here, first I am writing the general mechanism. So if you have alkyl aryl ether with OH, always the bond will break here, H will go here and RX will form. Now with example you can see, if you take anisole OCH3 with HI, we will get OH and CH3I. Okay, clear? Fine. So next question, anisole undergoes electrophilic substitution at ortho and para position. Explain. So the same thing how you explain for phenol, you need to write in the same way. Anisole, in anisole OCH3 is an electron withdrawing group which increases the electron density at ortho and para position. That is why the substitution takes place at ortho para position. You can draw the resonating structures and show here, right, how you did for phenol. You can see negative charge will come here, the negative charge will come here, and negative charge is coming at ortho and para positions. Okay. Next question number 33, explain the nitration of anisole and bromination in anisole. Okay, so if you want to see nitration in anisole, what will happen? We need OCH3. Okay, for nitration the reagent is concentrated HNO3 and concentrated H2SO4, right? Since it is an electron donating group, you will have ortho and para product, so you have OCH3 and NO2 group, okay, plus you have here OCH3 and NO2 group. Okay. Next you have bromination of anisole. So if you have for bromination, you take bromine with acetic acid. Okay. Now this one will give you OH and you have Br plus here you have OH and Br. Okay. Clear this one? Now question number 34, explain Friedel-Crafts alkylation of anisole and explain the Friedel-Crafts acylation of anisole. Okay, so here we can just write down the reaction, the same thing. If you have anisole, okay, for Friedel-Crafts alkylation you need CH3Cl and AlCl3. So this one will give you what you have here, OCH3 in presence of CH3, then you have here OCH3 in presence of CH3. Okay, now if you have this side CH3COCl AlCl3, so this one will give you what? Acylated product, right? You have OCH3 and OCOCH3 plus you have here OH, OCH3 and you have OCOCH3. Okay, done. So Friedel-Crafts acylation and Friedel-Crafts alkylation you can write down in two separate lines, do not write down like this. Okay, so this is what? Alkylation, Friedel-Crafts alkylation, and this is Friedel-Crafts acylation. Okay students, do not write like this and tell ma'am wrote like this in the board, so we will also write like this in the exam. You need to write two separate reactions. Okay dear, let's go to the next question. Explain the mechanism. Okay, now we have come to 5 marker question. These questions, see, these 5 marker questions are of 3 types, 3 plus 2, or are of the type 3 plus 2. In this 3 marker, you will get a reaction mechanism. There are 3 reaction mechanisms in this chapter. Any one can be asked in this 3, and we have discussed now 35 2 marker questions. Any one from that will come from here. So definitely we have prepared 5 marker questions as well if we just prepare this 3 mechanisms. Done? Okay. Now the question is, explain the mechanism of dehydration of ethanols to ethene. Okay, dehydration of ethanol to ethene. If you remember reactions of alcohols, we have reactions of alcohols were of 2 types. First is cleavage of OH bond, right? There we discuss cleavage of OH bond, acidity. So I am telling you again and again to memorize, to recollect, right? So I am also trying to recall again and again. So in the reactions of alcohols, first there are 2 categories, cleavage of OH bond, cleavage of CO bond. Under cleavage of OH bond, what I had? Acidity, that is, in that we had reaction with metal, and we have esterification. And here where there is cleavage of CO bond, there we had reaction with HX, then we had reaction with PX3, see I remembered, then we have reaction dehydration, and we have oxidation. Oxidation we discussed many things, but dehydration we didn't do any question there, because from dehydration we can expect only this mechanism question. Okay, so first we will discuss the dehydration of ethanol to ethene. Okay, this question has been asked how many times, you can just see this and guess how important is this question. So let us first complete the part A. I have discussed this mechanism here. So first of all, step 1 is what? Formation of, you need to write this mechanism 5 times today. Okay, you need to study and write down these reactions 5 times. Okay, so first of all, you take ethanol with H plus. Okay, it forms protonated alcohol. First is protonated alcohol is formed, step number 1. Second is formation of carbocation. So whatever this protonated alcohol is formed, that goes out. Okay, you did not explain these lines. Okay, this is not required. You just need to write these headings: formation of protonated alcohol, formation of carbocation. That's all. You write down this reaction here, O plus H2, we get a carbocation here. Here you should mention that this is the slowest step and this is fast step. Now once this is done, what is happening here? You can just write down elimination of a proton. So here, from here proton eliminates and double bonds come, ethene and H plus. Now you see in the initial stage we used H plus, again at the end of the reaction we are with H plus. So that is why H plus is used as a catalyst. It is produced with the reactions. Okay, clear first question. Now second question, if you see, identify A and B in the following reaction. So I told you that second part of this question is all that we have discussed in the previous. ONaCO2H plus. Can you guess this reaction? This is Cole's reaction. So what will be the product here? So I am writing here, it is like this. Okay, B1. Okay, I am writing like this. So we will get, here it is, Cole's reaction will give you salicylic acid. Next, this is breaking of ether, right? So you have this side C triple CH3 O C2H5. So what happened? You can see that you got C2H5OH, then this side there will be I. So we have the second one is CH3 whole 3 C and I. Okay, clear? Next we'll go to question number 36. So here we have given a different reaction. Identify A, B and C in the following reaction. 3 marker questions are there, and how to prepare phenol from aniline. So this we have already discussed. I'll tell you once again. Let us first focus on this one. So here also we have discussed this first one. So if you see, this is 36. Okay, 36A1. OH with bromine water, you will get 2,4,6 tribromoaniline. Okay, so you have Br. Here you have Br and here you have Br, right? Now second one, what is the reaction? OH with Zn. So this one will give you benzene with zinc oxide, right? Next, third we have C2H5ONa. So this is what? This is your okay, the reactions of alcohols with metal. So metals and alcohols will react to give you salt and hydrogen gas. So C is hydrogen gas. Okay. Now how to prepare phenol from aniline? So here if you see, the reaction is like this. First you take aniline, okay, aniline and then treat it with nitrous acid. Okay, you get benzene disonium chloride, N2 plus and Cl minus, and then you have water and you warm it. Okay, now this one will give you OH, that is phenol. Clear? Next, explain the mechanism of dehydration of alcohols to ether. Okay, so the previous question was dehydration of alcohols to alkenes or ethanol to ethene. Here it is alcohols to ether. Okay, fine. You can see how this one is happening. Here the first step is the same one, how it is taking place there, protonation of alcohols. Okay, you get here, this one is, one second, O plus H2. Okay, protonation of alcohol, step number 1. Now step 2, what happens? There is attack of the nucleophile or attack of another alcohol. So you have two alcohol molecule. Now this is O plus H2. So now what happens? This oxygen attacks on this carbon and this O plus H2 goes out. So this one happens. Then step 3 is what you can write down, deprotonation. Deprotonation. So from this O plus H, this H plus goes out and we get this one. Okay. Clear? That is this one. Now how anisole reacts with acetyl chloride. Okay, so that one I will draw the answer here. So just now we see this is your Friedel-Crafts acylation. So if you have anisole, sorry, here you have anisole, okay, OCH3, and it is reacting with acetyl chloride, that is CH3COCl AlCl3. So this one will give you what? This one will give you OCH3 plus COCH3, and you have here OCH3 and COCH3. Okay, clear? Next, question number 38. Explain the mechanism of hydration of alkenes to alcohols. This is where students get confused. There are 3 reactions, students. One is alcohols to alkenes, alkenes to alcohols, alcohols to ethers. Okay, alkenes to alcohols, alcohols to alkenes, then alcohols to ethers. Okay, just if you can imagine like this, you have reactions first, alcohols to alkenes. You have one reaction mechanism, alkenes to alcohols, alcohols to ethers. Okay, so whenever you read the question, read it properly so that you do not get confused about what mechanism is actually asked. Okay, so I will erase this, please draw this. Okay, okay, so I'll show you the mechanism here. Alcohols, that is the question here is alkenes to alcohols. So here first one is what? The same thing, protonation of alkene. Okay, so there is a protonation of alkene first, and or you can say formation of carbocation. Next, what happens? Nucleophilic attack of water. So this carbocation is formed, attack of water is taking place. So I'll explain once again. First, what happens when you do protonation of alkene? There is like water is present and H plus is present, and you get H3O plus. Now this alkene acts on this H2O and one H plus is released, okay, and takes this H plus, okay, and there a carbocation is formed. Now this water which is produced here again attacks on this one and we get this one, right? After that there is deprotonation to get you alcohol. So each of these mechanisms you need to write five times. One time you need to see and write, second time you need to see, first time you write from the book, first time see from the book and write down, second time write it again by understanding, 3, 4th and 5th time without seeing you need to write all the 5 mechanisms. 5 times means 15 times you need to write all these reactions. Okay, this is very important, a must question. Definitely questions will be asked from here in the 5 markers and you need to score here. Okay, fine, we'll discuss the second part of the question. Complete the following reaction. Okay, very simple. You can see 2 marker question, CH3, CH2, H2O, H plus, right? So what will happen? Markovnikov addition will take place. So I'll get CH3, OH, CH and CH3. This is A. Then if you take CrO3, that means what? Oxidation of OH will take place and we will get CH3, C double bond O and CH3. Okay, clear? Next. This is done. Next, question number 39. This is here this type of questions can also be asked. An alkene X C3H6 reacts with H2OH plus. Okay, so you have X, that is C3H6. So you can see this is an alkene. Okay, reacts with H2O and H plus. Okay, to give a compound Y. Now compound Y further undergoes reaction with CrO3 and H2SO4. Okay, CrO3 and H2SO4 to produce compound Z. Write the IUPAC name of X, Y and Z. Now if there is a 3 carbon and it is an alkene, then you know that is only one and only one alkene, that is propene. Now H2 and H plus will follow Markovnikov's rule, so we will get CH3, COH, H and CH3. Now with chromic oxide what will happen? There will be oxidation and we will get this one. Okay, acetone is formed here. Next, write the IUPAC name. So the first one IUPAC name is propene. Okay, the second IUPAC name is propane 2OL. Propane 2OL, and here it is propanone. Okay, now which among the following have the lowest and the highest pKa values? Okay, so first if I draw the structures, we have para-nitrophenol, okay, OH and NO2. Next you have phenol. Okay, next I have ethanol. Okay, and next you have orthocresol. So these common names you should know, orthocresol. Okay, now if I see that here definitely alcohols are having less acidic strength than phenols, right? So definitely phenols, alcohols will be least acidic and highest pKa value. Okay, and if you want to find the lowest, means most acidic, so OH is having NO2 group, which is an electron withdrawing group, it will increase the acidity. Highest acidic, so it will have lowest pKa value. Clear? Next, question number 40. How is phenol prepared from benzene sulfonic acid? Write the equation. Already we have discussed this question. How anisole reacts with methyl chloride? What is the effect of electron donating group on acidity of alcohols? So benzene sulfonic acid on heating with NaOH followed by acidification gives you phenol. This we have already discussed. Reaction you can see, oleum you take SO3H, NaOH and H plus will give you phenol. Okay. Next, how anisole reacts with methyl chloride? So once again, so this one just now we discussed, anisole means OCH3 reaction with methyl chloride, that is CH3Cl in presence of AlCl3. So here what I will get? Here we will get two things. One is OCH3 with CH3, okay, and then you have one more, that is OCH3 and CH3. Okay, what is the effect of electron donating group on acidity of alcohols? So electron donating group will do decrease the acidity, right? Electron donating group decreases the acidity, withdrawing group will increase the acidity. Okay students, so I can say now if you have done these 40 questions, okay, the complete, you see how I have taught you section wise. I have read each and every section and I have collected questions from them. No questions apart from this will be asked. It may be words may be changed or something, but concept, these are definitely are the most important, and I can say nothing apart from this you need to study. Just practice these 40 questions again and again, then your this chapter is done. Okay, I have personally read the book, I have collected these questions, so it is very, very useful, helpful, one-shot video for your alcohols, phenols and ethers. Now, I want to tell you some things that you should not miss at all from this chapter. You should remember most important topics. Name reactions, okay, there are so many important name reactions: Williamson ether synthesis, Coles reaction, Riemer-Tiemann reaction, Friedel-Crafts reaction and esterification. Now there are three mechanisms I told you should not get confused here: dehydration of alcohols to alkenes, dehydration of alcohols to ethers, hydrogenation of alkenes to alcohols. Okay, so these are the most important topics that you should do. Okay, so yes students, that was the end of day 4 PU2 Brahmastra series. I hope you would have enjoyed the series, and please comment down that you are enjoying the session or not, you found that easy or not, or any other doubts you have, please comment down, or any other problem you are having, please comment down. I am always there to help you and I will address all your doubts. Okay, so thank you students, and please remember this 50 questions you need to prepare today itself. Okay, all the very best for your preparation. We have to target centum in chemistry. Okay, so those who are ready to get centum in chemistry, please comment down, and see you soon in the next episode, that is tomorrow. And one more thing, that if you want these notes and PDF, please join our WhatsApp channel. For you need to fill the form. The form will be given in the description section. Once you fill that, notes will be updated in your WhatsApp channel. So please do not forget to fill the form, and rest will be everything provided to you. Okay, thank you for watching once again, and see you soon in the next class.